Hi, everyone. So we're here to talk about advancing web accessibility with ChromeVox. I'm Charles Chen, and I have two of my colleagues here with me, Volker and David. You guys want to say hi to everyone?
Hello.
Hi, everyone.
OK, so let's get started. So here's a brief overview of what we'll be talking about today. Start with an introduction about what is ChromeVox. David will take you on a walk through the DOM. Volker will discuss reading math. I will talk about how to use ChromeVox APIs in your own applications and web apps. And then we'll have a conclusion to sum up what we talked about. So with that, what is ChromeVox? Well, ChromeVox is a screen reader for Chrome, which brings the speed, versatility, and security to Chrome to visually impaired users. What's special about ChromeVox is that we built all of this with web technologies, such as HTML5 and JavaScript. So there's no impedance mismatch between what ChromeVox does and the rest of the web and your web apps. This allows us to advance accessibility at the same rate as all of you innovate and create new, exciting web applications and really push the boundaries of what is possible to do inside the browser. There are huge benefits for end users and web developers. For end users, you get a screen reader that's built into your system. On any Chrome OS machine, you just press Control-Z and it will start talking, so it's right there. It's also available on desktops. And for web developers, you get something really unique. You have a screen reader that works inside your browser that fits with your development workflow. You can do some work, run ChromeVox on it, and then listen to it and see what it sounds like. Because it is built with web technologies, there isn't any sort of mismatch between what you would expect in terms of what you can do with JavaScript and the underlying platform. The underlying platform is JavaScript and web. So anytime you want to do something that's custom, there is a way for you to do it. And we've opened up several APIs to help you create better auditory experiences on the web. And with that, I will now hand it over to David, who will give us an overview of how you walk through the DOM. So Chromebook is a little bit to the right. OK, perfect.
Thanks, Charles. Good evening, everyone. My name's David Tseng. I'm a software engineer on the accessibility team. I work on ChromeVox and Chrome OS. So tonight, I'm going to give you a behind-the-scenes insider look at how ChromeVox works under the hood. As you can see above on the slide, to the left, you have a pretty innocent-looking piece of markup. It's pretty simple, an unordered list of links and a editable text, input type equals text, and a button. So if you ask yourself, well, how does a screen reader actually take something like this and generate a description and make it possible for a keyboard-only user, someone who doesn't see the screen, to explore this content? How does someone do that? So I can take you through some alternatives and how ChromeVox actually does it. So you can imagine I could just take all of the text content inside of this UL, inside of the unordered list, and just speak it. So the problem with that is we don't get any of the semantics, such as this is a list and this is these are some links. So that's probably not a good idea. How about, say, let's let the user move from the structure of this markup. So we can imagine a system where we let the user land on the unordered list, let them move down into the links and move about in the links and move out, then go to, say, the editable text field. That's a little closer to what ChromeVox does. So what actually does ChromeVox do? Well, we centered around and we converged on the idea of a granularity. So let me define what a granularity is. A granularity consists of two things. Some notion of what a leaf node is, so how deep do we go in this tree structure, and what it means to go to a next or previous item. So I'll go ahead and show you what our base granularity is, which we call object. Now for this, we actually define a leaf node as any sort of interesting element, such as a link or a button or an editable text field, and the next or previous item just as one of these interesting items. So with that, I'm going to go ahead and enable ChromeVox and show you what it's like to navigate in this very sequential fashion.
Enabling spoken feedback. Article list with 4 items. Web link list item.
So this is the first interesting item, and you'll notice that ChromeVox said article and the text of the link and the role link, and played a earcon, which is analogous to an icon, just a sound representing some concept. So the article, which you heard, is the context, which means that this markup was surrounded by something that was an article, an ARIA role. All right, so if I continue navigating, I'll end up on another link.
Maps link list item.
And another link.
Images link list item. Gmail link list item. Google.
And that's actually a paragraph. So that's a basic introduction to one of our first granularities, object. So what are some other interesting granularities? Well, we also have defined a character granularity. And using that definition I just gave you, what does it mean? Well, it just means that the leaf node is now a text node, and the next and previous items are just the next and previous characters within that text node. So I have a command in ChromeVox to change granularities.
Word character G.
So now
O-O-G-L-E. Echo.
I was able to scan that text node just by walking through the characters. And you also heard a nice feature of ChromeVox that does a phonetic map for the letters. So if there's any ambiguity in the text-to-speech, such as an engine that doesn't have the clearest announcement of characters, we can give users another hint after a little bit of a pause and speak the word that phonetically can describe that character. So we have some other granularities, the usual ones that you would expect, word and line. So those are interesting because they break on different delimiters, and so the next and previous definition of the granularity is the only thing that we need to change there. So beyond these basic granularities, ChromeVox supports tables, and we were able to get tables to fit into this definition by saying, okay, next and previous are rows, and leaf nodes are just the rows, items, elements. And finally, we have some interesting developments that just got released with ChromeVox 27, which was just put up on the web store, that knows how to deal with math content. And with that, I will invite Volker Sorge to talk more on that subject.
Thank you very much, David.
Disabling spoken feedback.
So my name is Volker Sorge. I'm actually a senior lecturer at the University of Birmingham in the UK. But I'm spending a year working with the ChromeVox team here in California in order to work on getting mathematics spoken with the ChromeVox engine. And it is, in a way, a sad fact that what is still the biggest obstacle for fully inclusive education for visually impaired students is that much of the scientific content that's available out there is practically inaccessible. So at the ChromeVox team, we've realized this, and we're trying to make some way towards making some of this content accessible by at least making the mathematics that can be found on the web out there accessible via a screen reader. And as a consequence, we implemented oral rendering for mathematical content in ChromeVox. And if you're not familiar how math really works on the web, math is generally given in MathML format, or it's being rendered from either MathML or other formats using math checks. And with ChromeVox, we can now deal with both types of mathematical content that's on the web. As a consequence, math, or spoken math, is now supported on all platforms that support Chrome. So everywhere within a Chrome browser, you can use ChromeVox in order to have math spoken. And what might be particularly interesting for developers, of course, is that if you're, for instance, developing an EPUB 3 reader, you can leverage all the work we put into ChromeVox using the web views interface, and thereby, for instance, have spoken math on Android tablets or smartphones. Right, so let me dive into the details a bit, how math is actually being rendered. Usually it's rendered more beautiful than this, and I'll just tell you why this is the case. Right, here, this is how math is being rendered. And this is, you might recall this equation. This is the solution to the quadratic equation. Actually, it's two solutions. And the way it's being given generally on the web is by using a MathML markup language. MathML, as you can see on the left of this slide, is a fairly straightforward XML representation of what you have up there as the mathematical formula. So you can fairly easily map those, the x to the x and the equals to the equals, and then you have kind of a structured tree representation of what the math formula is there. Unfortunately, not every browser renders MathML straight away, and as a consequence, there's a tool out there which is called MathChecks, which can render math in all browsers similarly. And as a matter of fact, on this slide, actually, we use math checks to render the slide, and there was the little hiccup we had at the beginning because the rendering sometimes breaks a bit and you have to do a little reload. So on the right-hand side of the slide, you see how actually the math checks looks like. So if you have, for instance, the MathML in your DOM originally, then math checks will replace it in the live DOM in your browser with the right-hand side. And then you see immediately this is a lot less obvious what the mapping between the actual elements of the mathematical formulas is, as a lot of it is obscured by some of the markup that is necessary for the rendering. Right? Nevertheless, within ChromeVox, we can speak both MathML and math checks similarly. So the oral rendering is then done normally during the text navigation, and I'll show you how this then sounds. Let me switch on the ChromeVox engine again.
Enabling spoken feedback.
And now we go to the next math expression.
X equals minus b plus minus square root of b squared minus 4ac divided by 2a math.
Right, and so this is how it's being pronounced while it's in regular text. So you can hear we're playing a bit here with certain changes of the speech. For instance, we're changing the rate and the pitch when we dive in, or when we go into the nesting of, say, the square root or of the enumerator of the division. Also, we change the pitch when we go into subs and superscripts. As a consequence, you can hear where the square root actually ends and where then the division starts again. And nevertheless, in many cases, this might be too fast for you when you actually listen to this expression, in particular if it's a very large expression. Then what you then would like to do, and what we provide.
Disabling spoken feedback.
Let me switch off speakback first. What you then would like to do is actually start exploring the mathematical expression a bit further. And indeed, in ChromeVox, we now provide some functionality in order to do this. So what you could hear originally when you listen to the formula is that it's being announced as a math expression.
Enabling spoken feedback. X equals
Nobody should
minus b plus minus square root of b squared minus 4ac divided by 2a math.
Right, now it announced math. Now we know we have a math expression on our cursor effectively, and now we can actually explore it if we want to. So let's start exploring it. We have that's ChromeVox /
Entered math. X equals minus B plus minus.
I'll stop that speaking here, but you could hear a little earcon that tells you now we've entered the math expression and now can start exploring it. And you can now start exploring it just regularly with your cursor keys.
X equals X.
All right, so you can start the first thing and then
Sticky customizing
Oops,
math. Speech
now I made
rules
a
are
mistake here. Sorry about
customizable.
that.
Both disabling spoken feedback,
Let's go back.
enabling spoken feedback. Wrap to top. X equals
Let's enter the expression again.
entered math. X equals minus.
And now, we're stuck.
X equals
Oh, there you go.
minus B plus minus square root of B square.
Okay, I'll
minus
try this
4AC
one more time. I hope this
divided
time it's
by
going to
2A.
work. We enter the
X
expression.
equals minus B plus minus square root of B square minus 4AC divided by 2A. Wrap to top. X equals minus B plus minus. Entered math. X equals
Now we're in the math
minus
expression.
B plus minus square root
try
of
this
B
again.
square.
Nope. I'm sorry, this is the effect. Sorry, this is demonstration effect. If you come to our sandbox, I'll demonstrate this to you in detail. I'm not quite sure why this currently doesn't work. So the idea is, if I had been able to show that to you now, that you can actually enter the math expression and then start walking the math expression. Currently, this traversal follows fairly the syntactic structure. So you can listen to it x equals and then minus, and then the expression on the right-hand side of the equality. In the future, what we're currently working on and what will be released soon is that we have a more semantic way of actually exploring the mathematical expression, and in particular a way to customize this exploration. And
X equals minus B plus minus X equals minus B plus X equals minus B X equals my X equal X
there you go. Sorry. Now we actually are in the expression. Now it actually works.
equals
So now we're actually exploring the expression. If you can look, we're exploring the left-hand side. If you
X
go back, x equals.
minus B
Now
plus
we get the
minus
right-hand side of
square
the
root
expression.
B square minus 4AC divided by 2A
And now we can start exploring further. So we go a bit further.
minus B plus minus square root of B square minus 4AC
So if you still haven't fully understood what's in the expression, you can go further.
minus B plus minus square root of B square minus 4AC
And now you can start entering the square root,
B square minus 4AC
and so on and so forth. So this is the basic idea of how to explore the mathematical expression. And as you can see, we follow pretty much the syntactic structure as it is. My apologies that I fat-fingered this and it didn't work from the beginning. Obviously, now we're in the expression. Now we can also leave the expression again.
Cut.
And then once we're outside the
Disabling
expression,
spoken feedback.
we can then actually continue working with ChromeVox as normal. Right. Now, one of the major things about mathematics and speaking mathematics is, of course, that it can be a very different depending on the mathematical domain you're working with, and also depending on the particular style of mathematics you're doing. As a consequence, we build everything in ChromeVox in a very customizable fashion, which means that one can contribute to the way mathematics is spoken as, say, if you want to work on your favorite mathematical topic and you want ChromeVox to be able to speak all these things correctly, then you can contribute speaking rules for the speech engine as well, or for the ChromeVox engine, as well as just mappings for separate characters. For instance, here I've put down a couple of equations on the screen. One is just, say, a division followed by a multiplication, A divided by C times C, A divided by B times C. And on the right-hand side, if you're familiar with natural deduction calculus, which some of you might be from your logic class, then this is a natural deduction rule. And either way, you want it pronounced differently. On the one-hand side, you want it to be pronounced as divided by, and the other side, you want it to be pronounced as, say, the second part of the rules follows from the first part of the rule. And I've put down the simple JavaScript functions that allow a user or a contributor to customize our speech rules accordingly for the different expressions that you have. In addition to just customizing them by entering effectively different orders in which things are being spoken and entering different types of strings that are being spoken, you can also make optional changes to, say, things like pitch, rate, volume, as well as pausing for effect as we had earlier in the quadratic rule formula. Right, this is one way of customizing it, and then how can this actually be used by people that want to develop, say, an EPUB3 reader with it? Well, we have a fairly easy way to interface to the mathematics, as to everything in ChromeVox. And if you just pass a math node that you come across in the DOM at the right level to ChromeVox, either as MathML or as the rendered math checks in the DOM, then we have a fairly simple API function with which the node gets spoken, and you can leverage all the machinery that we put into ChromeVox in order to speak mathematics with your own app. And the particular API function here is just syncing to the particular math node. And there's some other API functions which I'll now ask Charles to explain to you in more detail. Thank you.
Thanks, Volker. So, we've talked about how ChromeVox works, as well as some of the cool new math features that are coming out. Let's see how you can use ChromeVox in your own web application. So, let me just refresh this page here. Okay. Okay, so why would you want to use ChromeVox APIs? Well, these APIs give you, as a developer, a lot of control. It helps you give ChromeVox hints about how it should be speaking content. It lets you give ChromeVox hints about where the user is in your application. And the most recent feature that we added with our last release of ChromeVox has been the ability to get at what the user is trying to do on your web application. So for example, on ChromeVox, as David was showing earlier, when you navigate, you can navigate structurally. So you can say, jump to the next list item or go to the next link, so on and so forth. But what if you, as a web developer, wanted to navigate, had a web application where it had semantic structure to it, but that wasn't necessarily exposed to the user? If the user wants to go to the next heading, your web app may be much better equipped to do that than ChromeVox. And so in ChromeVox, whenever the user tries to do an action, we actually send it to the underlying web app so that the web app gets first dibs on handling it. And so if it can handle it better, it can do it instead of ChromeVox and just pass the result back. There's full documentation available on this link, and these slides will be made available after I/O. But let's go through some code samples of how you can apply this in your applications. So, one thing that could be really useful to you as a web developer is to be able to speak custom messages. So let's see how this would sound.
Enabling spoken feedback.
Okay, so sometimes you may be doing something in your web application where visually it's obvious what's happened, but it would be useful to give someone who's using a screen reader such as ChromeVox an idea of what you actually did. So right now I'm going to, the code there is how I am going to make ChromeVox speak this next message.
Code highlighting off.
Okay.
Code highlighting enabled.
Okay, code highlighting enabled. And when I turn it off.
Code highlighting off.
Okay, so as you can see, visually it was obvious because code highlighting yeah, the code that I had bolded was immediately highlighted, everything else faded out. But it's nice to be able to auditorily convey that information. And so all it took was this one line of code here.
Code highlighting enabled.
You just call ChromeVox API.speak, give it a string of text, and it just speaks it. Pretty simple.
Speaking custom messages, heading
Okay.
3.
Now,
Sticky mode disabled.
okay.
ChromeVox API is speaking custom messages, function speak current slide.
Now, what you notice there is I flipped the slide, and it actually started reading the slide to me. So when it did that, this is another example of using a ChromeVox speech APIs, is that you can make it speak something. And I'm actually beginning to lose my train of thought here. I probably should have practiced more. But this is actually why it's really cool to have speaker notes. So let's try that.
Show how easy it was to add these APIs to the /show slide template.
Oh yeah, okay, that's what I'm supposed to be talking about. So as you can see here, when I press the key command to bring up the speaker notes, it actually spoke those notes to me. And now if I dismiss them,
Note hidden.
it tells me notes hidden, and it synchronizes me back to the top of my slides. On the other hand, if I try this on a slide where I don't have speaker notes,
ChromeVox API is no notes available.
it tells me no notes available. So I was actually pretty lucky there that I forgot my content on the slide that had speaker notes.
ChromeVox API is speaking custom messages, func code highlighting enabled.
Okay, and as you can see, again, it's really simple to do this. Again, it's just a simple ChromeVox API speak. By the way, you'll notice that in this case, I have a couple more arguments in there. These arguments allow me to control the voice. So if you listen carefully,
Show how easy it was to add these APIs to the /show slide template.
notice how that voice was at a lower pitch. So that's a way to give the user a little bit more flavor. In this case, it's to indicate that this is an aside. It's a speaker note and not main content.
Note hidden. ChromeVox API.
Now, another thing that's useful is if you're navigating through your application and a user wants to suddenly investigate more or try navigating from a certain point, it's useful to synchronize the user's position with where they actually are. And ChromeVox makes this really simple. All you have to do is just call API sync to node, and you will make, you'll basically tell ChromeVox that, hey, the user is over here right now, and it will position them at the correct spot. As I showed earlier in the notes slide, this is actually what allowed me to put myself back on the heading after the user dismissed the speaker notes. So it's great for focus management. And again,
Code highlighting enabled.
really simple there. The second parameter just controls whether or not to automatically speak or if you want to speak a custom message.
ChromeVox API is handling user navigation functions.
Now, as I mentioned earlier, sometimes your web application can do a much better job of navigation than ChromeVox because it knows its own semantic structure. In the case of these slides, when I'm not on a slide, all the other content is actually hidden, so it's invisible to ChromeVox. So if I were to search for a next heading without any help from the web app, I would actually fail because there's only one heading here. But since I give the web app the ability to respond first, you as the web developer can actually say, wait, I know how to deal with this next heading thing. I'm just going to do it. It's pretty simple. All you have to do is listen for these ChromeVox events.
Code highlighting enabled.
So you're just looking for a CVox user event, and then it has a detail object underneath it. And if you look at its command, it tells you exactly what the ChromeVox user is trying to do, and you can respond to that. And so I'm actually going to use that to navigate to my next slide by going to the next heading. Next heading.
Handling user navigation heading 3.
Okay, so as you saw there, it jumped me through that slide and took me to the next slide. In conclusion, what we covered in this talk was how you can navigate through the DOM with different granularities and how we're using the concept of granularities to support special content such as mathematics. And we gave you an overview of how to do this with the ChromeVox APIs. One thing to note is that this all works on Chrome. And as I mentioned before, this works on web technology. So this works on Chrome in any form. This is also available on Android. And it's actually a huge boost for developers because now you can develop on the desktop, test it out, and then when you run it on Android, you'll get the same effect. And these APIs are also available everywhere. In the audience, I actually see someone from Ideal Group there. Gar, you can go ahead and wave. So they're in our sandbox, and they're demoing their integration of their EPUB reader with ChromeVox Android. And they're taking advantage of ChromeVox ability to speak math to make their EPUB reader even better. What we didn't cover in this talk is that ChromeVox, we actually have Braille support on Android, and we're also working on it for Chrome. There's a lot more complex and advanced navigation features, such as working with tables efficiently. And then we also have HTML UI controls, such as datetime and media widgets. So
Less than thank you.
the best way to catch all that extra content is to visit our sandbox. And so please drop by our sandbox and come to our office hours. You can find all of this information on chromevox.com, and all of this code is open source, and these slides will be available after I/O. So with that, I see that we have about a minute left for questions. So any questions, please come to the mic. Sure.
I have one maybe silly question, but is it possible to set up a sort of a phonetic dictionary that you could, like as we were watching this, the I/O or the APs instead of API, could I just contextually say, for this period, I want you to, when you meet the word API, use the sound API, not AP,
Mm-hmm. Yes, so that is something that we definitely want to make easier and have it work better. In general, that's usually an issue with the text-to-speech engine, so you probably don't want to overcorrect for it. That having been said, we do have the notion of being able to tag HTML elements and nodes with hints. So it's in the API documentation, but you can basically tell ChromeVox exactly how a node should be spoken. And this allows you to pull in additional semantic information and speak it more intelligibly.
Would you be able to modify like a dictionary so you could say, the problem I've usually run into in this situation is you end up annotating every single instance when it'd be nice to just be able to have a dictionary of sounds, especially if you're doing science, reading science content.
Yes, so that's why we have the reading rules from Volker. Volker, you want to speak more to that?
Okay.
Well, for the reading rules, you can effectively annotate things. You can effectively even annotate single characters the way you want them to be spoken, in particular for certain mathematical symbols. That's important. It is, obviously, in many ways, it is like a dictionary that you can modify. It would be ideal if then some of these things that you modify on our end also would be spoken by the TDS engine, which is obviously also a particular problem with English TDS, which is not necessarily phonetic, but but you can do it.
Okay, thank you.
And ma'am, you had a question? Similar, okay. I think we're actually running out of time, so anyone else or, okay. Well, thank you. I hope you all enjoyed this talk. Please catch us in the sandbox.